Welcome to the Podkey summary of Get Started with the HTML Model Element from WWDC 2026. This week's story is really about 3D on the web, getting a lot less awkward. The big shift is a native HTML model element, a practical file format in USDZ, and a handful of tools that make building 3D experiences much more realistic for regular developers. And then around that, you've got the stuff that makes it usable in the real world. Smaller file sizes, easier AR handoff, better defaults for interaction, and some very honest limits when you fall back to a polyfill. It all adds up to the web inching closer to treating 3D like a first-class citizen instead of a side project. The headline is the HTML model element. Instead of pulling in a third-party JavaScript library just to place a 3D object on a page, developers can use a native tag and let the platform handle the rendering. That matters for a couple reasons. 1, it simplifies the stack. 2, because it's platform rendered. It can hook into capabilities the browser can't fake very well from userland. The clearest example is Vision OS, where the model element can render stereoscopically. So this isn't just a cleaner API, it can tap into depth and spatial presentation in a way a library alone can't really reproduce. And it's not some isolated experiment either. This is tied to an emerging W3C standard, which means developers aren't just coding toward one demo. They're potentially coding toward where the platform is headed. If the model element is the container, USDZ is the asset format people keep steering you toward. The big advantage is that it bundles geometry, materials, textures, and animation into one zipped file. That sounds tidy, because it is tidy. One file is easier to ship, easier to manage, and much less likely to turn into the classic web development scavenger hunt, where one texture goes missing, and your nice product render turns into a sad gray object. Safari can read other formats, but the recommendation here is pretty clear. Use USDZ if you want the best performance and the most consistent results across iPhone, iPad, Mac, and Vision OS. It also lines up especially well with AR Quick Look. So if your goal is getting from a product page to an AR placement flow without friction, USDZ is the safe bet. One of the biggest blockers for Web 3D has never been the viewer. It's the model. A lot of teams simply don't have ready-made 3D assets sitting around. That's where newer AI tools like Tripo 3D and Meshy.ai come in. The pitch is pretty approachable. Take a handful of photos, or even start from a text prompt, and generate a USDZ model you can actually use. The workflow being described is basically capture, convert, create. A 5-minute photo capture can turn into a ready-to-use 3D asset, which lowers the barrier quite a bit for smaller teams or developers working solo. It doesn't magically remove all quality concerns or art direction questions, but it does make the jump into 3D feel a lot less like you need a full studio pipeline before you're allowed to try. There's also a very straightforward integration path for AR. If you wrap a model element in a link with rel set to AR, that can trigger the native AR Quick Look experience on iPhone and iPad. For shopping or product demos, that's a nice bridge from seeing an object on a page to placing it in a real room. You tap, and suddenly the chair is in your living room, and you're making life decisions. On Vision OS, the same model element gets the stereoscopic benefit, which makes a regular web page feel a lot more spatial and immersive. And Vision OS can go further than a single object too, with immersive website environments where multiple models form a navigable 3D scene inside Safari. For interaction, one of the simplest features is Stage Mode Set to Orbit. That gives you an out-of-the-box orbit behavior where the user can rotate the model freely, and then it springs back to its default orientation. It also rescales the model a bit to prevent clipping while it rotates, which is exactly the kind of thoughtful default you want for product displays. It handles the boring but important part, so the model doesn't smash into its own viewing bounds. If you want more precision, you can turn orbit off and manipulate model.entity, transform directly with a DOM matrix. That gives you full control over the viewing angle. But now you own the problems too. You have to manage clipping and bounding box issues yourself. And if you want smooth motion, you'll need to animate the matrix with request. Animation frame, handling duration, easing and canceling overlapping animations. So there's a pretty familiar trade-off here. The built-in path is safer and faster, while the custom path gives you exact control if you're willing to do more work. For browsers that don't support the model element natively, there is a JavaScript polyfill that can emulate the API. That's useful and probably necessary if you want broader reach. But it can't recreate platform-specific features like Vision OS stereoscopic display. A polyfill can mimic behavior, not become the operating system. And even at the API level, developers need to test both paths. Some attributes can behave differently or just not exist in the fallback world, including cases like stage mode orbit on spatial platforms. So the advice here is pretty grounded. Treat the polyfill as a compatibility bridge, not as proof that every experience is identical everywhere. The other very practical part of this story is file size. 3D assets get heavy fast, and once you're on the public web, that becomes everybody's problem. A good example here is the command line tool USD Crush. A 7.9 megabyte USDZ camping mallet model was reduced to 1.9 megabytes, which is a 76% drop, with no perceptible loss in visual quality. That's the kind of optimization that matters way beyond neat benchmarks. Smaller files load faster, behave better on mobile networks, and make it much more likely that users will actually stick around long enough to see the 3D object appear. The long-term piece here is that this isn't being framed as one company building a private toy. Apple's Safari team is contributing to the W3C model specification and actively asking developers to bring feature requests and real use cases. That's important, because web standards get better when they're shaped by actual implementation pain, not just nice-looking demos. There's also support from the Alliance of OpenUSD, which provides a vendor-neutral USDZ spec and conversion tools. So the ecosystem around the format is being pushed as open, not locked to a single platform. Taken together, this all makes Web3D feel a lot more approachable than it did even recently. Native rendering, better asset workflows, AR handoff, and smaller files is a pretty solid combination. There are still caveats, especially once you leave the native path, but the direction is clear. The web is getting more comfortable with depth. And honestly, it's about time. This episode was generated by Podkey. Create your own at podkey.fm.